Welcome back to Way of the Wrench, and on this very special episode I'm going to be showing you how to use the brake lathe so that you can recondition your surfaces of your brake discs. That way you can save some money and reuse this part instead of throwing it in the garbage. Valuable gearhead information for you to know, so stick around. You're not going to want to miss it. So the first logical question would be, why do we need to machine these discs? Well, there could be a whole bunch of reasons. You might be putting on some new brake pads and the surface is no good, or you want a nice smooth surface for our brand new pads. You might actually have had a problem with your brake system. You might have had a seized caliper or something like that and let that pad material get down too far and had metal on metal damage to the disc. And the last one is that this disc could have gotten too hot and had some issues and been warped. And if you're not sure how to diagnose if your car has warped brakes, I'll post a link to a great video so you can 100% diagnose that for your vehicle. So all of these conditions require either a brand new disc, which is kind of a nasty way of doing things these days. We're starting to turn into a throwaway society. Rather than throwing this out, why don't we use a lathe and machine it so that we can reuse this part and be good on the environment. And while we're at it, we'll save some money too. Now, obviously, the first step in machining one of these brake discs is taking it off the vehicle. So if you're not sure how to do that, just refer to that link that I just posted on how to diagnose if you have warped brakes. Now, for today's video, I am using a Ranger RL 8500 combination brake lathe, which does discs and drums and even flywheels. But keep in mind, the procedures I'm going to be showing you right now are exactly the same for whatever brake lathe you have. Now, today's video is only on the brake discs. I will be doing another video for brake drum separately, so keep an eye out for that. Before we mount this onto the brake lathe, there's a couple things we need to do. The first one is we have to measure this thickness and see if there's enough material left on here that we can actually machine this and it won't be too skinny. Now, that specification before you throw it away is going to be in your Chilton or your Haynes or some kind of online repair manual such as AllData or Mitchell. So get yourself a micrometer or a vernier caliper. And in this vehicle's case, for a 2002 Mazda Tribute, the minimum spec before it is not able to be on the car is 22 millimeters, and this one is measuring at 23.5. So we have 1.5 mil, should be plenty to be able to clean this up, even though the one side is damaged as badly as that. Okay, the other thing we have to do is we have to clean up the surface where this disc is going to mount to the actual brake lathe adapters. If we don't clean up the rust and scale and whatever's on here, it may mount crooked, and we will be able to machine these surfaces nice and true, but that's only going to be true for when it's mounted in that way on the lathe. As soon as you take this off and put it back on the car, it is guaranteed going to be warped and you're going to have issues right off the bat. So we're going to clean this surface here and the other one in here on the angle where the tapered cone is going to center this. Now you can just use some probably about like 180 grit, 220 grit sandpaper, and you can manually clean it up. Or if you're lucky like us and you got an air compressor and some air tools, you can get one of these 90-degree air grinders, put a little sanding disc on it and clean it up nice and quick that way. Wire wheel will work as well. Now on this tapered cone, I'd recommend just doing it by hand because that is pretty delicate surface that we don't want to damage. All right, before we get going, let's do a quick run through on all the parts and what they do. All right, this is the spindle feed hand wheel. In order to move this, you have to have this unlocked, and turning this wheel allows you to position the disc that you're going to machine to the left or the right so that you can center it between your cutters. So left that way, right that way, and when you get it set where you want, you're going to want to lock this in place. All right, this here is the cross feed hand wheel, and in order to get this to move in and out or to feed when you're doing the machining, we have to have this unlocked, and you can leave this unlocked for doing disc machining. And clockwise makes it go in, counterclockwise makes it goes out. This here is the twin cutter tool assembly, and it's got two little carbide cutters in here that are going to be doing the machining for us, and we can position where they are with these little micro feed hand wheels, and when we get them in the right spot, we can lock them in place with these. There's a slot over here that if we undo this nut, we can position this to center it in the beginning so that we can machine our discs as well. So on these micro feed wheels, when you spin this, you are moving the cutter in and out. When you spin it clockwise, the cutter goes out. So what you're going to do is you're going to slowly feed this in until it just touches the disc. And then this black part actually moves independently. So now that we're touching the disc, we're going to spin this till the 0 line lines up with this index line. And now when we make any more of the moves on the end of the dial here, we're going to get an exact measurement that's off of here. So it gives you an example that each of these lines is worth 0.2 millimeters. Or if you use it on this side, it says it's going to be 0.002 inches or 2/1000ths of an inch. So now you can go in nice and accurately. There's my 0.2 mil or my 2/1000ths inch. Now keep in mind that this is only on whatever side you're adjusting. So the other wheel will be for the other cutter. And this here is the arbor where we're actually going to mount the disc on top of this quick change adapter, which I'll show you in a second. This is our control panel. There's an on-off switch, and when you turn this on, the arbor and the disc will start spinning. We have a toggle switch here to select which direction the machine will automatically feed in. So if you have it up, you're doing drums, it will feed this way. If you have it down, it will feed from the shaft out towards you. And this is the speed of the feed, so obviously slower to fastest. On this machine, there's 2 nice LED lights, and there's actually a little security safety screen that fits over these, so that when you get all set up, you can kind of have some additional protection from things flying up at your face. No substitute, make sure you're wearing safety glasses. All of these brake lathes are going to come with a whole bunch of centering cones and spacer blocks and anti-vibration belts and things like that. So you generally don't use all of this. It's more to be able to do every single vehicle on the planet. Some are cars, some are trucks, so that's why there's so many cones. For this Ranger brake lathe, they have something called a quick change adapter that's mounted in here already. And so if it doesn't look like this, what you're going to do is you're going to put your locator hub onto the arbor. Then you're going to put this 2-inch spacer shaft, and then there's kind of like a vibration self-aligning spacer that goes on. And then lastly is your arbor nut, and you're going to tighten that up. Once you have it set up like this, you can do discs and drums pretty quite quickly with what I'm going to show you next. Go ahead and make sure that this surface is nice and clean and there's no debris on there that's going to make it sit crooked. Make sure the shaft is clean, and then go ahead and take your disc on this side where it's flat. Make sure that's nice and wiped clean. Go ahead and put that surface against that hub. Now, next thing you want is a tapered centering cone. Make sure this is nice and clean, and this cone has to fit on the tapered side here on the chamfer of the disc, like that. If it's too small, it'll go right through the hole, and if it's too big, then this side right here won't actually even go in onto that taper. So this would be good for this one. I'll slide that on with the taper facing towards the machine, like that, and that's what's going to center this disc. Now, this is the nut that's going to go on. Make sure that the threads are to the back or going to be on the threads here so you can tighten it up. In some cases, you can tighten it with just this, but in this particular case, that tapered cone sits too low, so we actually need this adapter piece. And this little spring here is going to go on the end of that tapered cone and help push it in and make sure it's centered. And this is going to make up the space so that we can actually get onto the threads and tighten this up. So spring towards the disc, and then nut on. Now it's important to know that this nut is actually left-hand thread. So when you tighten it, it's actually lefty-tighty, not lefty-loosey. And the reason for that is that when we go to machine this, we're going to be grabbing out here, which would make the disc want to go this way, and if it was normal threads, that would actually cause this nut to loosen up. So because it's backwards, that's actually going to make it tighten up, and then this won't come apart on you. Okay, then take your spanner wrench, and like I said, tightening, we're going to go lefty-loosey. And it doesn't have to be crazy tight. You can just snug it up or give it a little kind of slight hit with your palm, and that's set up. At this point, not a bad idea to just turn it on, make sure there's no feed. Turn it on and see if it's drastically wobbling all over the place. If it is, you can fix it. So that looks like it's spinning pretty good. Now, whenever you mount a piece of metal in a lathe and you start machining it, when you have the surface that you are machining and it is far away from where you have mounted it, that can cause some vibrations. And when we are machining that nice smooth surface, it can actually do something called chatter, which is making a very rough, irregular looking surface, and we don't want that for this. So with this brake lathe, they send you these anti-vibration rubber straps, and they've made a rubber, and there's some lead weights on there to help kind of absorb those vibrations. So let me show you how to put it on. So all you do is you mount this to the outside edge or outside diameter of the disc, and you don't just put it on, you have to kind of stretch it, put a little bit of tension. And when you get to the other end, there's actually a hook on it, and you just hook it onto one of the end of those lead weights. And before you're done, just make sure that all the rubber and any of the lead weights are sitting centered on the edge of that disc so that they're not sticking out and going to get hit by the cutter when we're machining it. All right, in order to machine discs, you need to have this adapter mounted on, and there is a nut with an anti-vibration built in that needs to get tightened up. And before you tighten it up, you can actually adjust the position and the length that this sticks out. I would suggest that you have this as close as you can, as long as you can actually machine both sides of the discs. So you can adjust it this way, or you can actually adjust the spindle feed hand wheel on the end here to get that to move in and out as well. Now, in my experience, you will run out of distance here on most applications with your cross feed hand wheel. So what you may end up having to do is tilting this a little bit of an angle so that you can actually get that extra travel you need to finish up the job. When you think you got it figured out, go ahead and lock this in place. In this case, I've adjusted the spindle feed hand wheel as far back as I can, and that's the limit. So you can see that I am going to have to go out this way with this attachment. So loosen this up and extend it out. We can bring in the cross feed wheel to see a little better where we need to be. So for now, we're going to lock that in and see if it can actually reach all the way across the surface that we need to machine. So to be able to see if these cutters are actually going to be able to reach all the way to the inside, we're going to undo these lock nuts and then adjust these micro feeds all the way out to get those cutters as far back as needed. Okay, move the spindle feed hand wheel as necessary to be able to center the disc in between the cutters. Okay, now you can turn the cross feed hand wheel so to get the cutter as far in as it needs to be to machine that surface, and we're going to check if it's going to be hitting anything on the drum that we're not machining and whether both surfaces will actually machine. All right, now as said before, this is all the way in, so let's see if we can even reach as far as we need to. All right, so you can see we're a little short here, but we are away from the disc. So because these cutters are at an angle, if we turn the little hand wheel for the micro feed, we'll go in a bit more. And we're still going to be short for machining this entire surface. So, like I said before, we're going to have to move this twin cutter head in further or at an angle so that we can for sure get these. All right, we're going to loosen this nut that secures that twin cutter head, and we're going to angle it this way to make sure that we actually get the distance we need. Okay, and if I do that, that is definitely enough. Now the other thing we've got to be concerned about is the backside of this cutter. When we go forward, we want to get right to the corner, but we don't want the edge of the cutter to touch this part of the disc, otherwise it'll rub and you'll have some problems. So adjust this angle so that you can do both. So in this case, right there's the angle we need, so we're going to lock this nut back down. Okay, at this point, back these micro feeds, hand wheels back out, get the cutter out of the way, and then we're going to feed this back about halfway on the surface we're going to machine, and we got to do something called a scratch test. So before we machine this, the purpose of a scratch test is to ensure that this disc is sitting true so that when we put it on the car, we're not going to have a warp. So what we got to do is take a cutter and just gently scratch it on one side of the disc and then shut it off and see what that scratch looks like. Let me show you what I'm talking about. Right, make sure your feed is off and then go ahead and turn the machine on. Okay, we're going to loosen this lock and feed in the micro feed till the cutter just barely touches, hence the word scratch test. Like that. Okay, and then we can actually just back it out and go ahead and shut it off. With the machine off, take a look at the scratch, and in this case, because this disc is sitting nice and flush, this light scratch goes all the way around completely, so we know this is sitting nice and flat. Now, in a rare case where you maybe just get kind of like a scratched line like that, what you can do is you can actually undo the disc, put the slight scratch 180 degrees from where it was, re-tighten up the disc, and then repeat the scratch test and just move the cutter over about 5 or 10 millimeters, and then do the very same light scratch test. And if you end up with the two scratches exactly the same spot, then you know that this disc is set up true and you're good to go. If the scratch on the second scratch test moves to another spot, then you know that the disc is not sitting and mounted perfectly on this machine, and I would take a look back at this surface. Perhaps you didn't clean that good enough. So in this case, this scratch goes all the way around, so we know this is good to go. Okay, and then what we're gonna do is we're gonna turn this on, and we're gonna use the cross feed hand wheel, and we're gonna move these cutters up until they can get all the way far forward on this surface here, so the cutter tip can start cutting without touching this part of the disc, and make sure the other cutter on this side isn't gonna touch anything. And then you're gonna undo these locks and turn in the micro feed wheels until the cutter tips just touch. Once they're touching, then you can move it in a little bit more on the micro feed wheel, and then you're gonna go ahead and lock this in place. So let's go for it. Okay, undo this, move in the micro feed. Go a little bit more forward. Okay. Okay, so we're going to use the micro feed wheel and go until we just starts doing a little scratch kind of cut. And on the other side, the cutter actually will be cutting air. So we're going to go forward now with this wheel until we're right into the corner edge. Right there, it's cleared. Okay, and then on the micro feed wheel, each notch is worth 0.002 thousandths of an inch. So we're going to just take one notch and see how that goes, and we're going to lock this side down. Now we're going to undo the lock on this side and adjust this in till it just touches. Okay, and this one can go a little bit more forward. Okay, and then this side we're going to go in 2 thousandths of an inch as well, and then lock it. When you're ready to start cutting, we're going to push down on this to put it onto rotor feed, which means the cutter tips will start going out towards the edge of the brake disc, and then this controls how fast it's going to happen. So if you want to just take a quick light cut, or you know it's not going to clean up, you can speed it up. Or if you want a nice, smooth, steady cut for your last final cut, you can slow it down. Generally, you want to have it somewhere around 5 or 6 is where I find works pretty good. If you do go too slow on the feed, you can actually have issues with chatter. So if you do have that problem, you could turn up the feed a bit, and sometimes that fixes that. So feed down. And now simply just let it do its thing until it goes all the way to the edge and stops cutting. All right, on this side, looks like not much is coming off. Let's take a look at the other side. On this side, the cutter has finished about half the surface, so we just gotta wait till this one gets all the way to the end. All right, once the machining stops, go ahead and shut the feed off and shut it off. You can see that this surface is very nice and smooth. This is what we're looking for. Now this side is actually all the way around, looks like this, so really this one's done. We might just take one small, like 2,000th cut off this, just so that they're both being cut at the same time. But let's look at the other side. When we look at this side, it didn't even touch at all. So the very beginning here must have been where the pads were not touching and scraping off material here. So when I did the scratch test off of that to set it, that's obviously still a bit higher. So we're gonna have to do this one again. So let's do that. Remember, we're trying to take as little off as possible so that maybe even next brake pad change, this could actually be machined again as well. All right, shut the feed off, shut it off. Now, we did get a little bit machined here, but there's some pretty deep grooves, so we're gonna do yet another pass and same exact thing. Okay, a little better, still some really deep grooves. There's a lot of damage done to this. So we're just gonna keep repeating this process until this surface gets absolutely clean. Okay, now that the surface is cleaned up, we're gonna machine both sides with a nice final finish cut, about 0.002 inches, 2,000ths of an inch, and that should be our last cut. Smooth like a baby's butt. And for those of you thinking, man, I don't have time to sit here and watch this machine work, well, the trick is you don't have to. It has an automatic shut off to the feed, so it will just feed to the end of the disc. So you're free to go ahead and work on another vehicle for 5 or 10 minutes. When you come back, you can shut it off and check your surface finish. If it's done, it's done. If not, you just do another cut and go walk away again and work on another job. Okay, and don't forget, we actually made this a little skinnier with all this machining. So get your micrometer or your vernier caliper and check it against your all data specifications. So this vehicle was 22 millimeters, it's got to be thrown away. This is measuring at 22.7. So lots of meat on there to still go back on the vehicle. Okay, job's all done. Remove the anti-vibration belt. Okay, loosen the nut, and don't forget that it is reverse threads. And I find if you put all these parts back on in the proper order, next time putting another disc on here is even faster. And remember, we want to take care of our tools and equipment so that next time we need them, they work properly. So spend a couple minutes and do some housekeeping, clean up all the chips and shavings that came off of this. Okay, when you're using the rotor feed to machine brake discs, make sure this is off, otherwise this will prevent the cross feed from working. This would be tightened to prevent the cross feed from moving when we are doing drum brakes. If you're trying to get the cross feed working to machine the discs and you notice it's not working, it is going to be because this clutch is not tightened up. So make sure this is tight, and then you'll find that the feed is back engaged. All right, there we go. One finished disc ready to go onto the vehicle. And if you're not sure how to finish up that job, remember that it is part of the how to diagnose warped brakes video, so go ahead and check that out. Now, if you have any questions or concerns about what we did in the video, put it down in the comment section below and I'll get back to you as soon as possible. And hey, if you haven't already, why don't you join us on Instagram so you can see what's going on in the shop in between videos. Until next time, take it easy.